Hello students. As already discussed in my previous video that we have two interpolations formulas for unequally distributed intervals. So Lagrange's interpolation formula was one of them, and in our today's video we will discuss the Newton's divided difference interpolation formula. So to derive the Newton's divided difference interpolation formula, first we have to know about the Newton's divided difference table. So first we will try to make the Newton's divided difference table. Divided difference table. So suppose for example we are given with the points say x and y. Say we are given with the points x0, x1, x2, x3, x4 and x5, and the values of y at the point x0, x1, x2 respectively. So at the point x0 the value of y we are taking as y0, the value of y at x1 is y1, the value of y at x2 is y2. Similarly we have y3, y4 and y5. So say suppose for example these are our points x and y. So the first thing that we have to know about the divided difference table is first we calculate the first divided difference, that is delta dy, because this is the divided difference, that is why we are showing it as d. So the first divided difference will be equal to, this will be equal to first here, that will be equal to delta dy 0, which will be equal to y1 minus y0, y1 minus y0 divided by x1 minus x0. So the difference of this and this divided by the difference of this and this gives us the first divided difference of y. Similarly, here for this interval we will have delta t, that means the divided difference at y1 will be equal to y2 minus y1 divided by x2 minus x1. Similarly here it will be delta d y2, that will be equal to y3 minus y2 whole divided by x3 minus x2. Similarly our delta dy 3, that will be equivalent to, here that will be equivalent to y4 minus y3 divided by x4 minus x3. So now here in between them it will be equal to delta d, that is the divided difference y4, that will be equivalent to y5 minus y4 whole divided by x5 minus x4. So now this is the first difference, then now we will calculate the second difference. So our second difference delta square dy will be equal to, at the first point at this section it will be equal to delta square dy of 0 will be equal to, that will be equal to delta dy 1, this minus delta dy 0 whole divided by x2. Now we will take the difference from x2 and x0. Now the difference will be x2 minus x0. Then again at this point we will have delta square y1 will be equal to delta y2, that is this delta dy2, that will be the divided difference, delta dy2 minus delta dy1 whole divided by x3 minus x1. That means now we are considering after two intervals. So similarly, delta d square y2 will be equal to delta y3 this, delta y3 this, delta dy3 minus delta dy2 this whole divided by x4 minus x2. And at last delta square dy3 will be equal to delta dy4 minus delta dy3 whole divided by x5 minus x3. So next, when you are going to calculate it, next you have to do it for the delta 3dy, that will be equivalent to, so that means now it will be equivalent to, at delta 3 dy 0 will be equivalent to delta square this one y1 minus this one delta square y0 whole divided by delta 3 minus delta 0, this 3 minus this 0. So similarly at the next level, delta d cube y1 will be equal to delta square d y2 minus delta square d y1 divided by x4 minus x1 up 4 to 1. Similarly, delta cube d y2 will be equal to delta 2 d y3 minus delta 2 y delta d2 y2 whole divided by x5 this minus x2. Now again we will move on, then the next term will be, now I will write it here, that will be delta 4y, delta d4y, that will be equivalent to delta 4y0 here, that will be equal to delta 3y1 delta d3y1, this one I am writing dt because this is the Newton's divided difference, that's why I am writing delta d, so that it will not match with the Newton's forward difference interpolation, because we also have the Newton's forward interpolation and Newton's backward interpolations. Those interpolations are used for the equally distributed intervals. As here we are doing the Newton's divided difference interpolation, that's why I am using the delta d. I am writing the symbol as delta d cube. So this will be equal to delta d3 y1 minus this one minus this, that will be delta 3 d y0, that will be whole divided by x4 minus x0, x4 minus x0. So similarly the next symbol here, delta d y1 delta d4 y1, that will be equivalent to this one, this delta cube d y2 minus delta cube d y1 whole divided by x5 minus x1. So now we are left with only two terms, so this will be the final delta difference, so the fifth delta difference, so delta 5 dy, that will be equivalent to delta 4 dy y1 this minus delta 4d y0 whole divided by x5 minus x0. That means at the last term we are covering the whole points from point x5 minus x0. So the table will move on if we will be having more values of x and y's. So this table is known as the Newton's divided difference table. So now we have the Newton's divided difference table. This table is actually used for the unequal intervals. Now I will discuss with you the formula of the Newton's divided difference. So Newton's divided difference formula will be like, for example, we are having the points of, like we are given with the points of x as from x0 to xn. Similarly, we are given with the points of y as from y0 to yn. Now at a given value of x, say suppose for example in a question we are given that at a given value of x we have to find the value of y, or we can say this y as f of x. Fine. So for that what we do is the Newton's divided difference formula for that purpose is written as y is equal to f of x, because I am taking y as f of x, because we write the function as y is equal to f of x. When we are given with the point of x, we put the values of x in a function and we get the value of y. So if we are given, so the formula for the divided difference will be given as y is equal to f of x, that will be equivalent to y of 0 plus x minus x0 delta d y0. So the next term in the Newton's divided difference will be equal to plus x minus x0 x minus x1 delta square d y0. Similarly for the next term there will be three terms of x. So it will be x minus x0 x minus x1 then x minus x2 then delta cube d y0. Similarly, if we will have the fourth term, that will be x minus x0 x minus x1 x minus x2 x minus x3 delta 4d y0 and so on. So these delta d or these divided differences, like the first divided difference, second divided difference, third divided difference and the fourth divided difference, you calculate this by developing or by implementing the table from the given values. So now let's take an example and try to solve that using the Newton's divided difference formula. Let's take a question first and we will try to solve that. So suppose for example we are given with the question this. We are given with determine the Newton's divided difference interpolation for the function for which f of 2 is equal to 5, f of 5 is equal to 29, f of 10 is equal to 109. Also we have to find f of 6. Now first out of this we have to make a Newton's divided difference table. Out of these values we will make the Newton's divided difference table. Now say suppose for example, so let's take it as for example we will take it as I, that means the iteration I at the, so for example at the point 0, then at the point 1 and at the point 2. This we are taking at the point values, point 0 at point 1 and point 2. So now we will take the values of x, then we will take the values of y, then we have to calculate the divided differences. Number first will be the delta d y, the first divided difference, and then we have to calculate the second divided difference, that will be the delta square dy. Now first let's find out the value of x. See, the first value of x is 2 because our function is always in the form of f of x is equal to y. So here f of x is here 2, so y is here 5. Also here you can see the second point is f of 5 is equal to 29. That means our next point f of x, that is 5, and our y is 29 at the point 5. Similarly here we have 10, x is 10 at the third point, and then we have the value of y at f of 10, that is equal to 109. Now we have to first calculate the divided difference. The first divided difference, this, will be equal to 29, this, minus 5 divided by 5 minus 2. Sorry, y1 minus y0 divided by x1 minus x0. So if you calculate this, it will be equivalent to 8. So the next point will be equivalent to similarly this one. That means y2 minus y1 divided by x2 minus x1, that will be equal to 109 minus this 29 divided by 10 minus 5. If you will calculate it, it will come as 16. Fine. Then you have to do it for the second term, that means Newton's divided difference at second. That will be equivalent to this minus this 16 minus 8 whole divided by 10, this 10 minus 2, because we are left with only two terms in the first difference. In the first difference we are left with only two terms, that means in the next difference we will be left with only one term. So it will be 16 minus 8 divided by 10 minus 2. So if you will calculate it, it will be equivalent to 1. Fine. So now let's put it in the formula. As we know that the Newton's divided difference formula, y of x is equal to y of 0 plus x minus x0 delta dy 0 plus x minus x0 x minus x1 delta square dy 0. We cannot go beyond that because we have the terms up to delta square dy only for the Newton's divided difference table, which we develop or which we made for this function for the given question. So we cannot move beyond this, we have to stop here. We are given with only 3 points, so up to the 3 points the difference will be up to delta 2 dy. So when we will calculate it, it will be equal to, now we have to simply put the values in it. So as we know, our y0 value is this, so our y0 is 5, that will be plus x minus our x0 value is 2, our delta dy 0 value is 8, plus it will be x minus our x0 value is 2, x minus our x1 value is 5, and delta square dy 0, the value is 1. So when we calculate it, it will be equal to 5 plus 8x minus 16 plus x square minus 7x plus 10. So this will be equivalent to x square plus x minus 1. So this is our function. Now we have been given to calculate f of 6. That means our function is now x square plus x minus 1. Now we have to calculate the point at f of 6. That means our value of x is 6. So we can directly put the value in this formula. So it will be 6 square plus 6 minus 1. That will be equivalent to 36 plus 5, like that will be equivalent to 48. 1. So this is how we solve the question using the Newton's divided difference interpolation formula.